Hello everyone, welcome back to this Shanghai Tower Grasshopper tutorial. With the conclusion of the last part, we had what you can see on the screen. We had our parameters, our base profile, and finally our tower outlines with three output that we made from our previous code, our previous script that we can use in other parts of our script. Now in this part, we're going to be focusing on the panels, mainly the main panels, excluding the crown. So I'm just going to quickly bring up a old model. This is the part we're going to be focusing on. So as you can see, it's very minimal input. It gets a little bit busier in the middle. And as for output, what we're going to be looking at are the panels itself. Like I said, excluding the crown. So I can zoom in a little bit down there. You can sort of see what's going on. Not really sure if it's already visually clear, but you can see there's a gap between the panels in each floor. And that has to do with the system that is chosen for this design by the architect, by the Genslet design team. And I'll quickly bring up a Google search. So if you look for images, and you probably can come across this image to the right, where they explored options, these two options. One is a staggered, where the panels are perfectly vertical, and the other one is smooth, where the panels basically has a very slight angle. In the end, they chose the staggered option, where the panels are perfectly vertical. So hence you see the gap, because the gap is created by the as the tower gets higher, the radius gets smaller, hence you will have a gap. Now that's one output we don't have. We will be having, as far as the geometry is concerned. The other two are basically just infills, if I select them both, which is these exception panels that goes right up against the V-strike or the groove. And the rest are basically curves that we will be exporting. One is only the top curve of every floor, and the other one is the bottom curve of every floor. And then we have these, which are the V-strike or the groove curves that we can use in order to make the actual panels. I might include this into the previous script, into this part, because if I look at this, it's quite easy and quite small to do. So we might, if we have enough time, and this video is not too long by the end of the day, we will include that in. So with that said, let me turn these back off, and we'll jump into our own script and pick up from there. All right. So let's start with getting the parameters that we'll be needing for our next part. So obviously we will be needing, let me zoom in here a bit so that you can sort of like focus on a bit, or if you prefer, we can also do it in the middle. But actually, I want to start here because the less is on the screen, the more I can focus. So we'll take this, right? We'll connect that, and then we'll say you are hidden. So we want this one. The surface floor, we don't really need the surface floor because we're going to be going the whole tower. The radii of this one, I don't see where we can need that, but what we'll definitely need is the amount of floors. Oh yeah, we can now copy from this one. So we're gonna take the amount of floors, the floor height, and since we're including the crowns, we'll also take the crown floor. So we're gonna do a copy, Control C. Gonna come in here, Control Shift V, Control Shift V, remember that, so that it will paste in the center of a canvas, because I still have it in a clipboard. I'll show you what happens if I just do Control V. It's pasted, but where? Well, right here. And that's not what we want. So it saves you, if you have a big script, it saves you dragging all the way across a few kilometers on your canvas. So with that having prepared, now we can actually go in here. Actually, why did I turn that back on and off? Well, we'll take this one. The first thing we're going to need is to exclude the V-stripe. and then we're going to be focusing on the panels that's on the rounded facade. So one way to exclude this is we know, right? To cut this part off, the easiest way will be to identify the kinks, because we know that this part, the starting end, has a very sharp angle. So if we do a discontinuity and connect here, we get these points, which is where the curve has a kink. And I see 3 points, so expect 3 points also here, and that's confirmed. Now we can do is do a scatter of the curve so that we can cut it into pieces. And coincidentally, we have the t parameter, so we can scatter that part. And the reason, let me see why it's taking so long, is we have a problem with data tree. So we have a list, one branch. We have here 128 branches. So we need to graph, let's graph this part. And then that should be a lot faster. Because now we want every curve to be shattered according to the parameters, according to each branch of these parameters. So now what we will have is the curve shattered, 3 curves, so the big one, the smaller left side, and the other side. But we might not want to have these two separated for now. So what we're going to do is we're going to quickly do a sorting process in order to get those two out. So we're going to take the length. We are going to say sort. We're going to sort their length to the k. That's because the k always accepts only, let me say, accepts a number, and then synchronize it with the a. And what this will do is it will sort from small to large. So if I do list item and then I plug in the first a, list item onto the a without changing the index, I will get either of these two short curves. See? And so you can see here, one side we get the right side, and on other flows we get the left side. So we have to get that sorted out later on. But if I do another copy and I say number 1 index, I'll still get the smaller curve, because these two are obviously, no matter how you see it, it's going to be the shortest of these 3, like this one, and the big one. That's a no-brainer, I hope. So with that being said, let me quickly actually delete this, and we'll go get this up, and we'll just say here, let's you select those two. I'm going to multi-select this so that we can have those V-stripe curves out of the way. And in the other one, what we're going to do, we're just going to select the list item with the default index, but this time we're just going to reverse the list so that we're selecting the big one first instead of the smaller one. So if I cut this off, you'll see that we have now the big curve selected. So we'll do something with the V-stripe later, but not now. How we're going to approach this is, you might think, okay, let's now make a parameter that dictates how many panels we will have. Well, I have a different approach to this. Instead of selecting how many panels you want, we want to base that onto the V-stripe curve. And what I mean by that is, for example, let me take my trusty pen again. Let's say in the V-stripe curve, right, we have these panels, obviously, it goes all the way up. In the case where we will have 8 panels, oops, that's not an 8, I don't know what that is. Let's say we have 8 panels here, divided here, and so you have 4 on each side. What we want to do is actually, hey, take the width of that one of those panels and fit that all around. And what this will enable us to do is, the only thing we will have to dictate the width of the panel is by indicating how many panels do we have in this group. If it's 8, then the panels around it, try to match your width with this 8 panel. That will create some sort of consistency in your tower, because you don't want 8 panels here and then you have, I don't know, 300 panels all around, and then where the width of each panel is 50 centimeters, and then the width of a V-stripe panel is 1,500 millimeters, so 153 times as large. That will create some sort of inconsistency in your design, which I don't think anyone would like, unless that's what you perfectly want. Then you can probably adapt the script to it. But the way I would approach this is to make it consistent and make the panel width of around the facade based on how many panels we have in the V-stripe. So in a way, you can still dictate the course of the fineness of your panels, of how many you want, by simply dictating your V-stripe. Because this V-stripe can also change. Remember, we have a whole set of parameters that can change the whole basic shape. So if your V-stripe is a lot bigger and you have a lot less panel, then that will automatically mean that your different panel will also be very large. And vice versa, if you have a very large number of V-stripe panels, then every other panel will be also very small. So with that said, and with that idea out of the way, let's now actually create one parameter. Should I? Okay, you know what? Let's just create one here. I think this will be a global parameter. We'll copy that, and we'll call this V-stripe panels. We'll leave that at 8 because 8 is what's originally in the plan. So we'll copy this, right? We will come in here, we'll just paste this right there. So now that we have the amount of V-stripe panel, we can continue on with the script. I'll just quickly actually put a panel so we can have a look of what that is. But we're going to be using that very soon. So back to this curve. Now I mentioned there's a start and an end bit that we have to sort of isolate. I think that part will come up first. Let's start with this one. Let's see how we're gonna do this. First off, let's try to get the length out of these. And then we are now going to do an evaluation command. Yeah. Let's see. I think I might have to use this, even though I said we're going to be tackling this later, but we're going to be using this, a small bit of this for now. Now we have these two panels, these two lines. What I think we can do now is to just join them together so that we can have a singular curve. We can always scatter that back with a discontinuity, so that's not really a big problem. And we also have to solve the random switching of each curves on every level, so we'll have to tackle that anyway. So we have this part. Let's also take the length of this part. Now that we have the length of the whole V-stripe, we can start by dividing this by 8 so that we can have the width of a single panel, and then use that 8 for the rest of the bigger facade. Okay, let's start plugging this one in here. We'll definitely need that. And let's plug this in and let's bring in our V-stripe now from here. So let me create also a panel. All right. And for this time, I'm gonna make the expression in a panel. So first off, let's get the width of a single V-stripe panel, right? Well, we have the length here. This is going to x, so we're gonna say, give me x divided by y. So this number is going to be the width of a single V-stripe. So it's about 2 meters per panel at the bottom. Going all the way up, you have about 1 meter. So it's a reduction of about half, which is correct because remember our scaling was at the top 0.55. So that checks out. And now we have this number, which is the length of the whole lot, right? Now we can say, let's put this in parentheses. And then we can do a z divided by the width of a single V-strike. That will give us a number. For now it's decimal, but it's all the same because the panel gets smaller as it goes up. And this number is 136, so this number is, let me see, what's this? This is double. Yeah, so this is the amount of panels that you will have according to how many V-strike panels you have here. So instead of working with a decimal number, what I will do is, you can either do round it to the top or round to the bottom. So in this case, I'll prefer to round this to the bottom. So I'll do floor and parentheses the whole thing so that I can get a perfect round integer. I can actually now disable that because I don't need to see it anymore. All right, now we have the number of panels that we want sorted out. The next part, what we want to do is to extract the information that we will need in order to make the start and end exception panel that is adjacent to the V-strike. So because we have the amount of panels, actually let's make a component here, and then we can just call this number of panels. So that's easier for us to identify what that is, in case you forget. Now to get the other part, what we can do is to shorten this up. Let me see. I think an easy way is just do a curve extension. In this case, a subtraction or a shrink of the curve. So we're going to do curve extend. We're not really extending, we're extending negatively, so we're actually making it shorter, so we're shortening it. And how much to shorten will determine the panels that we have, and let me try to explain that first. So remember, we have a singular panel like this where we have a bit of, let me try a different color, where we have a bit of this, right? So naturally the top part, well, that's not that long actually. Naturally the top part is going to be shorter on this side at least, and the bottom is going to be longer. But on the other side, it's actually the opposite story, where you have the top part is longer and the bottom part is shorter. And to make the division, we can try, let's take 1/3 of a full width of that panel and assign that to the top part. Now, if it sounds confusing, don't worry. We're gonna try that now, and hopefully you'll see it visually what's going on. So first thing we're gonna need is, let's decide how much to shrink. So we're gonna do evaluate command. Obviously, the curve we want to shrink is that one, not the entirety. Wait, I thought I selected it. Oh, there we go. I might want to keep that shown still. And then we have the number of panels, and we have all the different lengths of every panel. But we want to find out what is actually the width of every panel on every floor. So we can plug that into here. We'll plug this one here, and then we'll make this into a panel also, as in the expression in a panel. We're gonna say x, which is the total length, divided by y, which is the amount of panels, gives us the width of our panels. I think we have that number somewhere. Oh yeah, we had it here, but yeah, we used it to get this. But anyway, this is still fine. So now we have these panels, right? We have the width of this. What we want is, all right, let's do 1/3. So times 1 divided by 3, 1/3. This will be the width that we want to subtract from here in order to get our exception panels. So if I were to, let's say, plug this into here, and remember, if you want to subtract from a curve using the extend, you have to put in a negative value. So I'm just going to quickly go here and say minus x, and I'm going to quickly copy this and do it the other way around. On the other side, we want 2/3. So we're basically shifting the panels. So if you plug this back in here, and then if I zoom in and select that, you'll see that a small bit is now excluded from one side and a larger bit on the other side. So if I disable this, you'll hopefully see it better. And now what we want to do is take our curve that we have here and, well, shatter again so that we can have these bits in a way where we can select them. And one easy way to do that is if you do a endpoints, like that, and then we'll do a point closest to a curve. The reason why we want this is we want a t parameter for our scatter, right? So we can actually just do, you may want to merge this or not, but I don't think it matters that much. And the curve we want to scatter, or want to drag the points to, is obviously our previous curve, which is this one. And now we can come in here and say scatter, scatter with a t over there, and our curves. And we're going to do the same exercise with sorting. So we're going to take the length of each curves, just to be sure. And then we're going to sort it asynchronous, or actually now it's just called synchronized sorting. Can disable everything else. So if I select a list item, it will be one of the short ones. I think the very short one on the right side, on the left side, sorry. There we go, the very short ones. And similarly, if you go index 1, you select the less short one on the left side, on the right side, sorry, and then the last will be obviously the bigger curve. So now that we have that sorted, we can now focus on the general panel first, and then we'll come back to do the exception panels. We'll start by obviously selecting out the panels that we need. So after the sorting, if I do a reverse on this one, I will always be selecting the bigger panel. So let me turn that one off. Let me slightly move it to this side. We can see a little bit better. I just don't like the sorting. Oh, actually, no. Let's put this a little bit like that. So we can still have a view of the outline, but not really obstructing our views. Alright, now we have that. Now the only thing we're going to do is divide this back into a polyline, a segmented polyline, so we can actually have our panel. So we're going to do a divide curve. We are obviously dividing this. And here is where you say how much you want to divide this, right? You can divide this by this number, or that number minus 1, however you see fit, because remember that this number encompasses also that small one here. So in a way, you could say, let's do this. Let's do x minus 1. It doesn't change a lot. It's probably like a few millimeters, but if we want to stay true to how many panels we've set here, but I think at the end of the day, you probably won't be coming back to it and see how many panels you want. But I think it's true this way. Let's say it's more consistent, and we want to strive for consistency everywhere else we can. Okay, now that we have that, we can do a single polyline. This one. We're just gonna make a new polyline. Oh, the P is where it connects. No wonder why is it taking so long? Okay. And with this polyline, what we want to do is actually get rid of the bottom one because we want the top curve to extrude down. And if you quickly look at the top, and the reason for that is if you take the top extrude down, you'll always be within your envelope of your tower. I think at the end of the day, it doesn't matter as much, but I think just dividing, extruding from the top to the bottom will give you less an issue, because the issue you only have to face is going to be at the bottom, but the bottom is just, well, it's the ground floor. So we're going to do a quickly calling index, this one, and we'll just select 0, unless 0 is at the top, which I hope not. Oh, right, we need to flatten this curve, obviously, so we need to flatten this one. Otherwise they'll call 0, which is one item in every branch. 0 is that item. So now that we have this, we can do a, let me see, what can we do here? Extrude. So we can extrude this down to the z-axis, obviously, from the floor height. Oh, we're gonna drag all the way. Oh, no, shouldn't let go. Floor height, come on. We'll drag that there. Yep, this is probably going to be a heavy. Oh, I should put one of these to be a minus, because now it's going to be extruding in a positive direction, which is upwards. And that is exactly not what we want. So we do minus x. I now actually see something strange, because this part does not check out. Now there's an easy way to fix this, is by simply wait, in order to avoid doing, I think we can do mesh wire, no wait, brep wireframe. Just do it like this. We can turn this off. You can see a little bit better. Yes, so in order to fix this, what you can do is you swap these two around. So instead of 1/3 here, you can do the 1/3 on the other side. Let's see if that works. So that comes back a little, but if I put this in here, it should give us a little bit more space to play around on that part. Like that. But that's not the solution that we should have. I mean, it's one solution if you want to keep the tower this way. I actually realized one big mistake in the initial setup. So I'm just going to quickly, let's lock our script, plug these two back in so we can save some time, and then unlock it back up. The reason why we had this error is not because of these two being swapped around. I mean, these two swapping around can solve the issue. But if we look closer, our V groove is actually wrapping to the right side, if you know what I mean. And if you look at the picture, let's see this one. It actually wraps the other way around. So to stay true to the design, to the original design intent, we have to modify something way at the beginning. Well, not really. There's somewhere here, because this is where we define our outline. So let's start zooming in, and I would think that it's where we start rotating it. That's where we need to correct our mistake. Well, it's not here, obviously. It's in the pipe. It's in the outlines. So we got the scaling, right? And then we have this one here. So it's easy to fix in the sense that we can just either put a negative value on the A, or we can put a negative value on this one. But since this one already has a degree applied to it, I don't want to add too much to there to avoid confusion. So I'm just going to add -R, and you'll see that the tower flips the other way around, which also fixes our problem with the exception panels that's adjacent to the V-strike, to the groove. And there we go. Let's swap to the other way around. So we can quickly zoom back in here and go in here, and then we can say actually the problem solved itself without us having to swap these two around. But if you prefer that your tower goes the other way around, you can just leave it like that, and then you solve it with swapping these two formulas. That should also be enough to tackle that issue. Now we can we can start to focusing on the exception panel, which is I will say the bigger challenge of all this, because you can see this is quite easy to do the regular panel. Now obviously there's still maybe one thing that we can do right now is get rid of the ones that's at the top, because that will be a different approach to remake those panels. So instead of doing every panel here, what we can do is, let me see, yeah, so we can start instead of just calling the beginning, we can call the top one, and that we need the crown floors. So we can start by saying let's make a series, start at 0 and has 8 numbers. We're gonna do another calling, and then we'll plug in these numbers here, but now we're saying, all right, let's call the bottom 8, but that's not what we want. If we reverse this and reverse this one back so that we are still counting from bottom to top, so we can see that we might have deleted one extra floor than we wanted. So we might want to change this one to x minus 1, so it subtracts one less floor, and then we can apply this to our extrude, which should make that ever so slightly less heavy to compute, I would say. So 10 seconds, 10.9 might be, I don't know, maybe ultimately 10.3. We might have to still come back here, adjust this number, but for now this will do. And for this, so that we can quickly go in and browse, because if you display the whole surface, it's gonna be very, very laggy. Now with that said, we'll focus now on these exception panel, the start and the end. Okay, we'll start on the left side. So should I, you know what, let's do this. Let's give this a different color so that we can quickly identify while still be able to see it. We'll leave it as white. That should be fine. All right. Now we just come back to the list item where we have here. I want to put this around here so we can see better what we're doing. I'll just copy it down below. Get rid of this there. We'll just call this panel 0 or index 0. So that we're selecting that side. Now, the same exercise we have to do here is to, as you can see at the very bottom curve, we actually don't need that one. So what we're going to do is we're going to call the same thing we've done here. We'll call that one off. Now we have the top one. Now we need the bottom one, this one right there, so that we can loft these two together. And one simple way to do that is we actually have the data here, or actually not that one, the one before the calling, which is this one, or actually even further before the whole scattering. It's not this one, it's not that one, it's this one. We want that point. Okay, so let's do a curve from here just to make it a little bit clear for us of what we're doing, and then we can do an endpoint. If we do a list item from this endpoint, we can see which item we want, and we can turn that back off. So these are the points we want. You can build in a checking in the sense that if you're not sure that start is always going to be that point, right? You can do point closest to the curve that you want, which is the one above. I find it hard to believe in a scenario where the point will be closer to the other side, right? So you can actually evaluate both points and always be sure that you have the right points. But at this time, I don't think that's needed. If it's needed, it's only a switch that we need to do. So if you do experience a problem later on when you complete the script and you try to modify it, then this is where I would suggest you to look at or to build in that checking mechanism, the checking component, to make sure that you always have the right curve selected. So with that being selected, what we can do now is we have, well, not this one, actually this one is the top, because we know the panel goes straight down to this one. So we can actually do a move. We'll move this. Actually, let me quickly disable. I think it's easier if I just minus X this one instead of the other one, because then I can reuse the same move. Enable that back up. Well, that'll be 10 seconds of calculation. We could have started with maybe a shorter tower. That way we don't have to wait 10 seconds for every time we have to do the same trick. So we move that back down. So you can see here the curve is now moved down here. And that's faster if you want to get this curve rather than having do a, I don't know, some sort of like a list Parametricks built from there. Now with that being said, we can do another exercise with the, so we can actually do this. Let's do this with the endpoint. So we're going to select that one. And now we can come in here and start creating our lines. So this one, while it's an arc-like curve, we want to make them into polylines. So the quickest way will be to just do a endpoint and then create from there a single line. We'll close that. We'll make another one here. Now, I think, let me see, where is the stop point? Because this is quite important for us. So if we start from right to left, basically. So we want to do the same actually here. We want to start right to left. That's 1 point. Why is that 1 point? Oh, right. I just, right. Yeah, as you can see here also, we need to graph this. I don't know why this is here. So we're just going to skip that. And I think we'll just flatten this part so we can have that curve. So now if we do a merge, and in this merge we'll graph the input so that we can have each line going to their respective branch. The same for this one. So we have 127 items there, 128. So obviously we have one too many, and I am thinking it might be at the very top, which it is. Something weird is happening over there. That's because we still needed to call off one of the top curves. So for this one, we want to call off the top one. So we're just gonna quickly get that here, and then let's see. We want to reverse. No, actually not reverse. Wait, we do want to flatten. That curve is not going away. Are we calling the right curves? Because we want the bottom one, so obviously we want to do this. I think I might have to flatten this one in order for the reverse to work. There we go. Because now I'm saying it has to do with the order of things, but to rather not fiddle around with that on the input here, we'll just do it on the previous input component so that we flatten that part, we reverse it, that way 0, the index we want to call, becomes at the top. And then we just reverse it back so that we have the right line going to the right places. Now we might have to call again at the top, but we'll worry about that later. So we have here how many? 128, 127, 127. So we go, let's take the original curve to that. And then we can do a simple loft. Like that. Now, since this component is quite quick to compute, and we know the crown on, at least on the left side, it starts on the left side, it rounds up to the left side. What I mean by that is it will start from here and then it will round like that to the top, which means for us that we have to get rid of the top few section, but that's easy to do because we've done it where? Here. So I can just take this part, we'll just copy that one over there, we'll just pull this back in here. Yeah, so the same happens. I need to flatten this one first, so I don't need to flatten it here now. So I might have to flatten this part, actually, just to be safe. So I'm just gonna do that, flatten. Wait, does this go? Oh, right, this go there, and this go there, and this will, oh, okay, right. If I wanna make this very neat, I'll have to get rid of the flatten over there because it's not needed. Even though they don't really do much, but I prefer that not to have a double flatten when one of the flatten basically doesn't do anything. So we got this part. I think I might have to fix something here. I don't know why. No. What happened? 127, 127. No, it shouldn't be a null. Okay. Let's reloft this. So I'm just gonna quickly make a new loft. Aha, the data trees are not the same. So let's simplify that and simplify this so that whatever data tree it comes in, it will be the same thing. So we can get rid of that now, just to be sure. Alright, so if we zoom back out, you see that it stops where we want it to stop. And then we can control this amount of how much the crown flow will take. So that's one end. And we'll go and reproduce this for the other end by first going into this one. So this one's obviously going to be 1, like that. And then for this one, we're also going to be calling off the bottom section, like that. And then this one was that part. We can actually reuse the endpoint of that part, so we don't need to copy that part. But we do need to first create our straight lines, convert the arc curve to a straight line, and then we can create a new. I'm just going to quickly do a geometry to double check what we're dealing with. So we have that point. Wait, do I even need that point? Oh, right. Right. So this is where a different challenge begins actually. We don't want to connect there, and the reason why that is I'm not sure if I can show that. I'll try to bring up a picture. So I pre-selected this picture, and the reason why I'm saying that we can't do the same exercise as the other way is because if I can draw on my screen, and if you could focus on the right side, top right, we're now doing this part, right? This part was relatively easy to do, but if you look at here, the panel starts roughly the same size where this one will start. But if you look at the other panel, let me smaller brush, there we go. If you can just see this panel, the underside is a lot shorter than the top one. So this one is actually an exception panel within the V-strike. And that happens because of our groove that turns one way or the other. So we will have this problem. So we need to solve that in a different way. Let me hide that and minimize this and get back in here. So if I were to draw the same thing on this panel, and I hope that I can. So if that is about, so half is here, then you have another panels here, and then you have this panel. Obviously you have, oops, yeah. Obviously you have the panelization. So here, you don't want to connect there, right? You want to connect somewhere there so that you can have, let me use a different color again. So you can have this go down like this, stopping here, and well, imagine that to be a straight line. Actually, I can take a straight line here. So this is not a perfect rectangle, okay? So that creates a problem for us because then we need to create this part right there and this line instead of going to that point, which will create a slightly different angle for these two exemption panels. So that's a challenge that we have because of this curve that would go the other one way or the other. The other way is easy because it just it's how this geometry is set up. Our solution to this problem would be to do it in this way. We know we have this line. I suggest that we can take the upper line, we move it down, and then if it's not enough, we can extend it. Oh, I should use a different color. We can extend it, right? And where it crosses, that will be our point. And then we can use that to create our line. And we might be able to use the same point to modify the V-strike panel that's also in this region that needs to be modified. So with that said, that's well, that one can go. We don't need that anymore. This point, oh, that was just for the visualization. I'll leave that here for now. So we have this one. This one needs to change. And we need the groove lines. I believe it's this one. Yeah. So let's do a curve. We'll just extract that. Yank that back down here. We'll flatten this part. I suspect that we don't need the top part, but we'll see what we'll do with it. Well, 1 to 28 items. Yeah, I think we should probably just do that for now. So what I'm doing is flatten this. I don't need to flatten this anymore. Reverse once, reverse again, so that I'm eliminating the very top curves because we don't need that. We're dealing with the bottom curve. All right, and now we need the top curve on the way there. That's before all this, so I think it's this one. Yep. On second thought, let's create this. Move everything a little bit there, and I'm gonna quickly create a curve from here. Oh, we might need to wait 10 seconds for the other one again. So that I can have the complete curve, and then I can move it down and see where it intersects. I might have to do some, yeah. Or actually, I don't need to do this. Wait, I'm actually going, this is improvising on my original script, because in the original script I did it a little bit differently. But I can actually take that and move that one down. Why not? So if I take this, where's my Z? Is it this one? Yeah, it's this one. Well, let's move it all the way here. We'll move you down. There we go. This is a lot better, actually. I mean, for sure, it will. Let's check the top, because the top. Well, except for that one, obviously. Or not, I don't know. But for now, let's call off the top one. So, sorry. In order to make sure that we have 1 to 28, 1 to 28 items. Oh, wait, this is not it. I was going to panic, like, why am I having 1 to 27? So this is 120. Oh, wait, that is also 127. Ah, wait, that doesn't matter. We moved on. I was looking at this part. So that's okay. So that's solved. To make sure that we are dealing with the right item, so we have list item number 1, that's at the bottom. List item number 1 from here is also at the bottom. Cool. Now we can do a curve-to-curve intersection. Curve. Okay, I don't know where it is. I do know where it is here. It's a physical curve-to-curve. So we want to intersect you with you. We should have 1 to 27 points. There we go. And the nice thing about it is we can actually have these two parameters here. We can use that to call the V-struct panel, the groove. But we're not going to be using that one first. We're going to be using the A. Yeah, it's the A. So we're going to do a shatter of this curve based on that. I'm going to hide everything. We're going to do a list item. This item, I should have 2 items per branch. Yep, I do. Now, in first glance, you might think like, hey, we are selecting the right curve, it seems. Well, Grasshopper can have the tendency to switch that around, if you know what I mean. So in order to avoid that, what I suggest that we do is we take, let's take this one, the endpoint from that one. Let me hide this one. It's getting a little bit distracting. So let's hide this one. Or wait, actually no, I need to see it. Sorry about that, guys. Because I need to know which one I'm calling off. I need to show that one still here. There we go. Right. Actually, so it's just a graphical glitch, it seems. I was beginning to wonder, like, why is my curve extending beyond the point where I tell it to cut? But it's just a graphical glitch on my end, at least. I need to because I'm using a 3D mouse, and the 3D mouse basically snaps to a point on geometry, but since none of these are real geometries in Rhino, it doesn't know where to snap, and hence probably snaps to a point that's far away, which create these artifacts. But I can quickly fix that if you have the same problem. Select a single item and focus on the item, and it will center your camera again. Anyway, that's one trick. Now we have this. What I wanted to do is to say, let's do a curve evaluation. CRV evaluate. We are going to be evaluating both curves. We'll quickly reparameterize it. I just want a point, basically. That's what I'm getting at. Well, why do I have so many points, actually? Oh, right. I see. I have 32,000 because one of these needs to be grafted. So I'm just gonna, if I graph that, I need to graph this one too. Okay, with the power of editing and hindsight, my script actually crashed because I accidentally grafted one of these. So my advice would be to stop, disable this component before you graph any of these. What I would advise would be seeing at this one is purely used for that part. We can just graph this, but we're not just gonna graph it as is. We're gonna disable this component first because then we're gonna have a big trouble. We might graph this one too. Let me see. Yeah, so I'll just graph both and we'll simplify them just to make sure that the path is going to be correct. So I'm just going to quickly kill this, disable that, I'll graph that one. Since this one has a reverse on it, I actually maybe rather graph them here. Yeah, you know what? I'll just do, wait, what are these? These are geometry. So I'm just going to quickly do this, all right? And I'm gonna graph this one instead and simplify that, also simplify this. So I'll plug that one there like this, and I can actually just now enable this, and now it should not crash and give me these points that I actually wanted. Alright, so that was a little bit of a speed bump. So with that said, what we want to do is we have these 2 points, right? We want to, according to these points, select the right line, which is always going to be the line that's in our view right now on the right hand side. Just to make sure that I always get that line, we're going to do a point closest to point, and the point the closest to is that one. We've actually got that from here. You can actually directly take it from there or just plug in a in-between component like this one. So let's see, point to search from is the P, and the C is the cloud points to search for. So I will plug in this one. Now what this would give us, okay, is, well, sorry, no, not that one. Actually this one. We might have to graph this again. Seeing as this one has a branching system, so if we simplify that, we have 127 branches, so we might have to graph this one too, just so each point is searching from their own branches. So we put that in here, and what I hope to see, actually let's put in a panel. I actually want the index. So the index, the closest index of closest point. So obviously these are all 0. And if I look at this list, none of them shows 1, which is a good sign, but just to make sure, we're going to use that index into selecting our lines. So that in a case where, in a weird way, I don't know how, that one of these lines actually flipped to the other side, that we don't really care. We've taken care of it because we are always saying the logic behind it is sound. We want the line that's closest to this point and not the other way around. So that gave us that, and this I believe is now a straight curve, so we can actually have this, let me see. Yeah, so now we can loft these together, although I might have to make this into a straight line. Are these still arc? Line like curve? Oh yes, of course they are lines to begin with because they come from a line. All right, okay, and what's that? Oh, that's the other side. Well, we don't need to see that. Oh, this is a copy. Well, we don't need that one because we've used that one already. So we got these lines and we have the other line. So this is how many? This 127. We have 127 here also. And now Actually, let me copy this merge because this merge already has these two applied to it. We'll take U, okay, and we'll apply U here. Let's see what we get. Great. I can get rid of this. Don't need that. Now, if all goes well, we will have the loft that we wanted. See how it stops right there? And we go all the way up. I believe we haven't applied anything, but this is fine because this one does go all the way up. We might have to fix the top one, but that's a later issue. That's a very minimal issue. It has to do with the crown and how we construct the crown. But at this stage, I'm pretty happy with this. So that, oh yeah, of course this is excluding the top crown, and this one you don't have to. So with that enabled, enable that one. Should disable this one, and you see if I enable that one, you have the whole part right here. I think we might have some time still to tackle the V-strike curves geometry. So we have these two, and we're gonna leave it on. We're gonna control save this, and all right. So let's move on to the groove. I think we can still fit that in here since we have built some components here that we're going to use, especially these points. All right, to move on to the V-strike, it's we first have to identify our input, which I have enabled here. So we know that we've combined it here, and it gets separated into A. We're going to be using that number too. But first off, let's rename this so that we can have, so that we can visually see where our input should be coming from. So there's that. And this one is just calls the very top one. We might have to do something there, but maybe, yeah, we might have to do something there. But before then, I want to do something like divide the curve. So we can divide this one, or we divide here. Doesn't matter as much, but what we're going to do is quickly take a number. We'll bring that down just so we have an easier way of connecting these lines instead of zooming in and out. So this is 8, obviously. So we turn that back on. You can see we'll have 8 per side. As I've explained, this one is the bottom one. As you can see, the bottom curve is highlighted, while if I zoom all the way to the top, you can see, oh, I hope you can see that the very top curve is not highlighted because that's what we done here. We called off the very top one. We might want to do the same, but then vice versa, and then work with that one. So this one is actually the one that I need. So I might just do this instead, and then disable that. And we can actually copy one. You know what? I'm just going to move this here to the top. And for this one, we are going to be culling the bottom one and not the top. We're going to do the same thing here. We just create another cut. Actually, let's move this back down because of the component that was already attached to it. We just need to remember that this is bottom and the other one is top. But anyway, so we have this line and we need to cut them off. So the easy way to do that will be just to make a polyline. Polyline, like that. And the polyline goes obviously on these points. And once you have these, so let me disable that. Let me show you. So once you have the polylines, right? And I might need to disable. All right, that's that. If you have the polylines created in that way, and if you explode your polyline, you get your segments, which is in the S. So we're just gonna quickly copy this for that one also, so that we have both up and down. Okay. Now I mentioned that we are going to be using this number, so we have to identify. And why would I need that number? Well, the reason for that is if you forgot or haven't really followed is we wanted this line, right? We wanted to be substituted so that it stops right at that point, right at this point, because that's where the RF panel stops. And then what we're going to do is just basically just let it loft like that instead of lofting the whole panel. So with that, let's clean up and continue that. I need to identify again. So this is the top. The top is fine. We don't need to touch that. But we do need to modify this. And we need to modify specifically the very right hand side curve. And we can do that with the power of this one. Now, one way we can do that is we are going to do a sorting process again. We're going to say, hey, give me the center point of every line. And then we can say the point that is closest to this point, that's the curve we want to substitute. Okay, so we're just going to do a point closest. I can actually copy from this one. So the cloud point, before we go into that though, I need to make sure that I'm selecting the right point. So if I briefly come in here, flatten this, sorry, this is the point at the bottom, so that's good. I'm gonna plug that one here, and we're gonna plug these. How many do we have? We have 127 branches versus 127 branches, so that's fine. So we got our point selected, and we have our index. I believe our index is gonna be all 8 or something, 0 in this case even. So this could have well been 8. So that just means that the curve starts from the right hand side to the left hand side, but that's fine. We don't hence that's why we're doing this, so that we can make sure that the script just works irrelevant, independent of how the ordering is structured within your script. So we have this part, and then we're gonna do a we're gonna substitute the point. We have the index, we have these two. Well, I don't need that one. I need this one. So what we can do is I should list item this. Actually, we're going to list item the first one, right? And then we are going to do a endpoint from that line so that we can extract both points of the end. And we're going to substitute one of the points with, let me disable this one, with this one right here. So we might have enabled that. And then we're firstly going to identify where is the start. So the start is basically on this side. And let me see. Well, the chances are in the same argument that the start might be flipped. If that is the case, then we will have to build in a additional checking mechanism. But for now, I'm just going to quickly take the endpoint, seeing as, or actually the start, because remember that the line now goes from the right to the left. So we'll take that from there, and we'll take the endpoint, and that gives us a line. Now that we have the line, we need to, let me simplify this. We need to put it back into this list. And what we can do that is simply using a replace. So we're replacing that list. Might as well just simplify this also, and this one, just to make the structure a little bit clearer. So we have this point, right? And we're gonna simplify, we're gonna replace the item replace with, well, that's this one. Where is the item you want to replace? Well, that integer is here. So now, if I enable this, you'll see that it stops right there. And the data tree is also the same. So if I, again, simplify that, get a nice, beautiful line. And I can actually move this a little bit like here, and then I can do a merge. I should just copy this one. Now, since these are already grafted, and each branch has 8 items, but what I ultimately want is every branch should have two items, which is the top curve and the bottom curve. That's it. Hence, this grafting on top of this graph will create that additional branch structure for us. So for example, let's start with the top. So if I hover here, you can see there are two levels of branches, right? And if I put this one here, you see that we'll have 2032 branches, each branch with two elements. So now if I do a loft, we get this. A nice loft. Don't worry about the overlap still. Oops, whoa, something goes wrong. There we go. Reset my camera view. So if I zoom all the way in here, you can see that it lines perfectly with each other. So this go all the way up, and then we're gonna encounter a different issue we're gonna tackle later on, which is on this side of the V-stripe, the panels don't exist, these 4 panels, because that's where the crown starts. But that's something we can tackle in the next part. So to summarize, what we've done here is we've got, I might have to pull this all the way there, because that's what it was, because these are the output. So if I briefly enable that, we got this, the curves, the panels, and the exception panels at the end of that's adjacent to the V-strike. So we might have to now make some adjustment. You can actually delete that if you want to. Doesn't really matter now. I think we'll create the parameters that we'll need based on the ladder script. Yeah, so create the output parameter that we need from this part as we go. I think that will be a little bit more efficient. So I'm just going to quickly do that on screen now instead of off screen like I did in the previous tutorial. I'm just going to quickly Control C, Control Shift V, and I'm going to add this to the group, and then we'll call this general panels surfaces, just to make sure, because well, these are not solid geometries yet. And this one you can delete. We'll Control save that again. So with that said, I'm gonna end this part right here. I think it's a little bit lengthier part than the rest, or than the previous video. So I hope you've able to get this far and maybe learn a thing or two with especially with the algorithm that we've done here, just to make sure that we are where things doesn't rely on manual input, that we leave that to the computer to do, to build that into a script into a smart way. But as far as this video is now concerned, this part, I will end it here. I hope you've learned something new, and I'll see you in the next one.